This video is over chapters 11 and 12. Chapter 11 talks about the living ocean. Some things that I've learned that in the 19th century, Charles Darwin and Alfred Wallace thought of the theory of evolution. This states that the population will gradually adapt to take on the traits of the most successful individuals within that population, immediately leading to the development of new species. Taxonomic systems were developed about 250 years ago by the Swedish Carolus Linnaeus and are still used today to the name and classify related groups of organisms. Taxonomy is based primarily on shared morphology. Planktons are gradually smaller and are unable to move faster than the horizontal currents, so they drift with the water's overall movement. The euphotic zone is the area of the ocean where there is significant sunlight for growth of photosynthetic organisms. The aphotic zone is the area of the ocean where no light penetrates. In between is the dysphotic or twilight zone, where there are significant light to see during daytime, but not enough light energy to support photosynthesis. The depth to which light penetrates varies depending on the number of factors that are 1. The angle at which the sun rays hits Earth's surface, 2. Absorption of different wavelengths of light by water itself, and 3. The amount of particulate and dissolved matter in water. The salinity of surface waters from different regions of the ocean differ depending on the climate, proximity to fresh water source, season, temperature, and circulation patterns. Whether an object floats or sinks in water depends on the difference between the buoyant force which pushes an object up and the gravitational force which pushes the object down. An object sinks, its density is greater than the density of the water. Oxygen enters the ocean in two ways: a byproduct of photosynthesis by marine phototrophs and through equilibration of surface waters with the atmosphere. The richness and variety of life found on our planet are referred to as biological diversity or biodiversity. Things that I found interesting is that the most abundant source of energy in the ocean is sunlight, which both heats the water and supplies the light energy necessary for photosynthesis. The temperature of 90% of the ocean is remarkably consistent and varies from about 30 degrees Fahrenheit to 40 degrees Fahrenheit. About 20% of Earth's surface is frozen, including the sea ice in the Arctic and southern oceans. All life on our planet is based on carbon. What I want to learn more about is, since all life on our planet is based on carbon, does this mean that if we don't have carbon, we wouldn't live? Questions that I have for this chapter is, what made Charles and Alfred call it the theory of evolution and not something else? And how does light provide energy? In chapter 12, it talks about the plankton productivity and food webs. Some things that I've learned, that at about half of the oxygen we breathe comes from microscopic, single-celled marine photoplanktons, which are not true plants. Seaweeds or macroalgae are large plant-like algae. Plankton are also organisms commonly less than a few millimeters in size. Photoplanktons use solar energy to generate oxygen in the organic food that fuels most of the rest of the life in the seas. Zooplanktons are composed of unicellular as well as multicellular organisms. Bacterioplankton are composed of members of the domains Bacteria and Archaea. Phytoplanktons are less than 2 to 3 microns in size. Microscopic photoplanktons are often referred to as the grasses of the sea. While most of the photoplanktons in the ocean are harmless and small subsects can produce toxins, discolor the water, or otherwise negatively impact human and wildlife health, which is referred to as harmful algae blooms or HABs. HABs lead to animal mortality due to direct physical contact or irritation fills, development of low oxygen condition during bloom decay, and formation of ecology disruptive algae blooms or adabs. Zooplanktons are heterotrophs and they consume other organisms. Something that I found interesting is that all photosynthesizing photoplanktons in the ocean contain chlorophyll. The more photoplankton in the ocean, the more color shifts because chlorophyll strongly absorbs blue and red light. The green light is reflected. What I want to learn more about is photoplankton's primary productivity is controlled by temperature, light levels, and inorganic nutrient concentrations. The question I have about this chapter is how exactly do viruses come about in water? This concludes chapters 11 and 12.